Okay. Hi, everybody. A very good morning. I hope you're doing great. So I have to be made host. Okay, cool. Right. So I'm made host now. Right. So we have enough number of people. I think we can start. Let me share my screen. Right. Okay. So hope you remember last class what we saw, right? We were seeing different nucleophilic addition reactions of carbonyl compounds, right? So we saw some important stuff, right? You can remember acetal formation, hemiacetal, acetal, right? And when we have two OH groups the same in vicinal diols, if you have, you can going to form a cyclic acetal like this, right? We even saw those kind of structures. And then we went on to see HCN, what happens in HCN, right? When you have HCN, you're going to form cyanohydrins, right? All those things we saw, right? Deprotection, protection, these are all extra for you. Don't worry about it. Okay. And then we went on to see this bisulfite addition, right? Addition of NaHSO3, right? This is actually a test for carbonyl compounds, right? Because the compound formed is going to be a white precipitate, right? The compound formed is going to be a white precipitate. So that you'll be able to understand if the white precipitate forms. Okay, fine. We understand that it is going to be a carbon compound. Okay. And then we saw next one was addition of ammonia and its derivatives. Okay. We saw NH2Z. We know what is the shortcut also. We just have to remove H2O. Where is it? Yeah. NH2Z is there. From H2 from N and O from carbonyl compound. You remove that and make a double bond. Okay. And we saw the mechanism also, how it is exactly going to happen. Right. Okay. Then what we have is this different amino derivatives and what are the products formed. That also we understood, right? The names, the structures, and the reagent name and the product name and the carbonyl derivative, the structure, everything is very, very important. Okay, we saw all those stuff, right? Okay, so then we went on to see this reduction reaction, right? So your aldehydes and ketones can be reduced to your corresponding alcohols, all right? Okay, then we have this, we have strong reducing agents, weak reducing agents. LaAlH4 is a very strong reducing agent example. NaBH4 is another example for weak reducing agent, right? So whether you have aldehyde or ketone, aldehyde on reduction will give you primary alcohols, ketones on reduction will give you secondary alcohols, right? So you used, but there is a specialty about NaBH4 and LaAlH4. I think we saw it somewhere, right? I told you that LaAlH4 and NaBH4 is not going to touch your double bonds, right? So you understand, right? So for example, if at all I have LaAlH4 or NaBH4, this double bond what I have here is going to stay as such. But the ketone part or the aldehyde part will get reduced. That's okay, right? But if I use H2 bar nickel as the reducing agent, then definitely both the aldehyde or ketone part as well as the double bond and triple bond part, both of them will get reduced. So the double bond is gone. You understand here, right? So that's what is written here. LaAlH4 and NaBH4 does not affect C double bond C or C triple bond Cs, or in general, they don't affect olefinic bonds, right? And I think this is where we start. And we saw the mechanism also, very, very easy, right? From LaAlH4 or NaBH4 comes your H minus hydride, right? And that is again an example for nucleophilic addition. This H minus is going to attack the carbonyl carbon, the bond breaks, and eventually you will form this one, and eventually it is going to take up H plus to form your alcohol, right? We saw the examples also. All right. So this is where we start last class. Any questions anybody has? Okay. I suppose everybody is okay. Right. Fine. So now people, now we are going to deal with oxidation. Right now we are going to deal with oxidation of aldehydes and ketones. Okay. Right. So people understand that aldehydes can be oxidized to acids, right? Whereas ketones cannot be oxidized. Ketones cannot be oxidized. Anyway, they cannot be oxidized at all, right? Because you understand that if at all I have a CHO, that is an aldehyde, that on oxidation can give C double bond to OH. Right? But ketone, since I have another carbon atom here, there is no possibility of putting OH there. That is not possible. Okay, so ketones cannot be oxidized, but aldehydes can be oxidized with any oxidizing agent, either strong oxidizing agent or a weak oxidizing agent. You will be able to oxidize your acids, aldehydes to corresponding acids. Say for example, if you have CHO like this, and say you put KMnO4, which is an oxidizing agent, right? And we know that CHO part will now get converted into COOH part. Very simple reaction, right? That is about, and ketones cannot be oxidized. Only aldehydes can be oxidized. Okay, right? Fine. So that is about your aldehydes getting oxidized, oxidation reaction. Right. Moving on, and we are going to deal with the most important reaction of this particular area for the particular chapter, and that is your condensation, aldol condensation reactions. Right? Aldol condensation reactions. Okay, right. Fine. So in this, what are we going to do? The aldol condensation reaction is given, or say it is happening because of presence of acidic alpha hydrogen. And this point we have already proved, right? We know that aldehydes and ketones have acidic alpha hydrogen, which we have already proved in the presence of tautomerasin. If you remember tautomerasin, right? What happens in tautomerasin? I remove the H plus, shift the double bond and make O minus, and then attack the H plus again to make the enol, keto enol tautomerasin, if you can remember. Okay, so aldol condensation reaction happens because of the presence of acidic alpha hydrogen. Okay, right. So what exactly is going to happen here? We'll try to understand. So aldol condensation reaction, for the main requirement for a compound, for an aldehyde or a ketone to give aldol condensation reaction, is that at least one alpha hydrogen should be there. At least one alpha hydrogen should be present. Because the entire reaction is happening because I have acidic alpha hydrogen. If no alpha hydrogen is there, there's no reaction happening. Okay, so at least one alpha hydrogen should be present for aldol condensation reactions to happen. All right, fine. So now how the reaction goes, we try to understand. Right. So people say, like, before we move on to what is the actual reaction. So if I ask you, say benzaldehyde I have. Okay, I have benzaldehyde. Can this give aldol condensation reaction? Can you tell me? Benzaldehyde we have. I hope you know what do you mean by the circle. Okay, we have basically double bond, double bond, double bond. Okay, so is it possible for benzaldehyde to give aldol condensation? Can you just give yes or no? Yes, can this give aldol condensation reaction? This aldehyde, can it give aldol condensation reaction? You know what is the requirement, right? The requirement is at least one alpha hydrogen should be present, right? So will it give aldol condensation?
No, sir.
No, sir.
Okay. Yes, we understand that this is your carbonyl carbon. The next carbon is what is your alpha carbon. And you understand that there is no hydrogen here, right? This carbon doesn't have any hydrogen. So this cannot give aldol condensation. Okay, right. So keep that in mind. Only if you have alpha hydrogen, then you can go for aldol condensation. If not, no reaction will happen. Okay, right. So let us try to understand what exactly is happening here. Okay, so let us take some aldehyde. See, okay, what about HCHO? Will it give? Okay, forget about this now. What about HCHO? Can it give aldol condensation? Can HCHO give aldol condensation?
No, sir.
No. You understand that this is your structure. First of all, there is no alpha carbon at all. But there is only one carbon. The carbon atom next to the carbon is what is alpha carbon, and the hydrogen atom present in that alpha carbon are what are called as alpha hydrogen. First of all, there is no alpha carbon at all, right? So definitely this is not going to give any aldol condensation. Okay, fine. So we'll see what exactly happens in aldol condensation, right? So for example, we have CH3CHO. Now we understand that this is your alpha carbon. Yes, it is having some hydrogens. So this can definitely give your aldol condensation. Okay, right. So the reagent required is a base. Right, the reagent required is a base. I know what is the role of the base. The role of the base is going to be abstracting proton, abstracting H plus from the compound. That is the role of the base. Okay, that is why we go for, say, dilute NaOH. Let's write it here. right? So the base generally used is dilute NaOH. Okay, or we just write OH minus. That is also fine. Okay, all that we require is a base. Okay, fine. So now if you put a base, right, we know what is going to happen. Let me write this as CH2H. This is your alpha position, and I know this is your alpha hydrogen. No issues. So what is going to happen? This H plus, this CH bond will break so that the electrons are going to go to carbon, and the H plus, the hydrogen, is going to lose electron, and that will be taken up by the OH minus. Okay, that will be taken up by the OH minus. So now what is going to happen? We have this CH2 minus C double bond OH. This is what we have. Okay, CH2 minus C double bond O with the H. That's what we have. Okay, now we have a carbanion. This is an example for a carbanion, right? Okay, now we have to take two molecules of the same thing. Okay, we have to use two molecules of the same thing, or this is an example for an, okay, let me come back to it later. So we have two molecules of the same thing. So we have another molecule, CH3, C double bond O with the H. Okay, now we understand that this carbon is going to have a del positive because the bond is polar and stuff, right? And now we have a carbon with a negative charge. Now that can come and attack your carbon. And if that comes, this bond breaks. If that comes, this bond breaks, right? So now what is going to happen next? Let me start with the CH3, and it is having a CO minus and a H. Okay, and this carbon is attached to this carbon now, CH2, C double bond O with a H. Very simple, right? Okay, now what are we going to do? We remove a H plus, right? You add a H plus, right? You add a H plus to this O minus. So we are going to have CH3, CHOH. This CH I'm writing as CH like this, OH, and that is attached to CH2, C double bond O with the H. Right. This is not the final product. This is your aldol actually. Alcohol with an aldehyde. Alcohol with a ketone. Generally, those are what are called as aldols. Okay. And these aldols will undergo dehydration. How dehydration is very simple. Right. Let me write this as, here I write it as CH. Now what I'm going to remove is this water molecule. Okay. OH from this, H from this. Okay. So now we are going to end up with CH3, CH, double bond CH, C double bond O with the H. Okay, right? So this is the entire mechanism. Again, I'll show you what exactly happened, people. First step is removal of H plus, alpha H plus from the carbonyl compound. Okay, once you remove the H plus, you form a carbanion. Okay, you take that carbanion and make it attack the next molecule, this carbonyl carbon, because that is having a del plus. Okay, if you do that, the C double bond O breaks, and we are going to end up with this kind of structures. And after you form the O minus, take up a H plus to form the alcohol. That is your aldol. Okay, and from the aldol, you remove the H2O, OH from this, the AH from this one to form this kind of compound. Okay, so people, what we really need to understand is that aldol condensation reaction will form the aldol exactly to be like this. You are going to form a beta hydroxy aldehyde or ketone. Beta hydroxy aldehyde or ketone will be formed. You can understand here. You can understand what kind of aldol is formed. This is your carbonyl carbon. This is your alpha position. This is your beta position. Right? In the beta position, we will be getting an OH. That's why we call it as beta hydroxy aldehyde or ketone. Right? So that is going to be aldol. Not only in this reaction, any reaction for that matter you take. Right? You are going to have, this is the aldol, beta hydroxy aldehyde or ketone will be the product. Okay. Now, what should be the final product? The final product is going to be an alpha beta unsaturated aldehyde or ketone is what is going to be the product. Okay. Alpha beta unsaturated aldehyde or ketone is what is going to be the final product. Aldol is beta hydroxy aldehyde or ketone. Now from this, basically you remove water molecule. H2O you remove from this to form alpha beta unsaturated aldehyde or ketone. Right? So that's exactly what is formed here. You can understand that this is your main carbon. This is your alpha carbon, this is your beta carbon, and between the alpha and beta carbon, there is going to be unsaturation. That is going to be a double bond. Right? Okay. So the aldol form will be a beta hydroxyaldehyde ketone, and from the aldol, you remove H2O to form alpha, beta, unsaturated aldehyde or ketone. Very, very simple. Okay. Right. So, like if I give you another example, will you be able to do like this? Say if I give you acetone, CH3, C double bond O, CH3, 2 moles of this, and I'm going for OH minus. Okay. Can do this. Now you understand that this is alpha question. This is also alpha question. You can remove any one hydrogen, no issues. You can remove this or this. Anyone you can remove. Do the same thing and you can send me in WhatsApp once the mechanism is done. Show me the aldol, show me the mechanism first, then show me the aldol, and then show me the final product, condensation product. This is your condensation product. Okay, aldol product and the condensation product, everything you have to show along with the mechanism for this particular compound. Okay, can I do this and send me in WhatsApp? Hope you guys are doing. Do not sit idle, people.
So can you show me the above reaction?
Sorry, hold. Yeah. This is the reaction.
I have just copied. So.
Yeah, yeah. Okay, okay. So once you're done with this, tell me, I'll move the page.
So can you move it?
Yes, is it done?
Hold on. So the last equation is CH double bond or two.
Yeah, CH double bond CH, C double bond to H.
So before that beta carbon.
This is CH3. CH3, CH double bond CH, C double bond to H. Okay.
Yes, sir.
Right. So now you can do this question. Or maybe I'll help you with this question. Next question you can do for yourself. Right. Okay. So if I ask you, I mean, if I just check, this is your alpha hydrogen or this is your alpha hydrogen, anyone you can take. Right. So let me write this one as CH2 H. Okay. Now what are we going to do? We are going to break this bond and this OH minus takes up the H plus. Right. So what we'll have? We will have CH3 C double bond O with the CH2 minus. Okay. And you're going to take the another molecule of the carbonyl compound, same carbonyl compound, CH3 like this. And this is going to come and attack your carbonyl carbon and this bond is going to break. Right. Then what is going to happen? You just have to write the compound properly. Let me start with this one. CH3 CO minus with the CH3. This is done. And you attach this carbon with this carbon. Right. So this carbon is attached to this one, CH2, C double bond O, CH3. Done. Okay. Now what will you do? You will remove the H plus, you add the H plus to the O minus. Okay. So we are going to have CH3, COH. Now let me put the CH3 down and let me put this thing up and this thing down. Okay. So we have CH3 here. That is going to have CH2, C double bond O, CH3. Right. Now remember that this is your aldol. Okay. And we are understanding, right? This is your main carbon, alpha carbon, beta hydroxy aldehyde or ketone is what is going to be the product. Right. Okay. Now what you have to do? You are going to remove one H2O from the alpha and beta positions. Right. Okay. Let me write it like this. CH, H. You'll remove the H2O like this. Okay. So you'll write minus H2O to form a double bond between this and this. Right. Okay. So we will have CH3, CH3, double bond between this and this carbon with a hydrogen, C double bond O, CH3. This is your final product. Alpha, beta, unsaturated aldehyde or ketone is the final product.
Sir, can you again explain the last before step, sir?
This one?
Yes, sir.
Okay. Right. So you understand that first the carbon will attack the carbonyl compound and this bond breaks and this is the compound formed. Okay. Right. So this O minus is going to take up a H plus. Right. This O minus is going to take up the H plus. So it is going to become OH. That is no doubt. So what I did here, I see this compound and like I just replaced this CH3 coming down and this coming up. Nothing. The same compound is written in this way. Right. The CH3 is here. So you have to understand that this carbon is attached to CH3 and the same carbon is attached to CH2. This carbon attached to CH3, this carbon attached to CH2. This is just a way of writing, nothing else. And from this, you remove the H2O molecule to form your final compound. That's it.
Okay, sir.
Okay, right? Fine. So that is all right. Okay, fine. So now let me give you another question. Say if I give you CH3, CH2, CHO 2 times, and I'm going for OH minus. Okay, guys, you can try this out now. Right, show me the mechanism, show me the aldol, and show me the condensation product. Everything you have to show along with the mechanism. So first step would be to remove the alpha hydrogen. This is your alpha hydrogen. This is your alpha carbon. You have to remove this hydrogen. Carbanion. Attack the next carbon compound. Make the aldol. Remove H2O to form the condensation product. Very, very simple only. Please do not sit idle. Go for it. This is the time for you to practice. If you're not going to practice here, you will never get to practice anywhere. Okay, something I got. Who's this? This is Rohan. Oh, Devesh. Devesh, this is your alpha carbon, right? This is the carbonyl compound. The next compound carbon to that is what is alpha carbon? You have to remove hydrogen from here, not from here.
Sorry, sir. Sorry.
Right? Do it again. Do it again. Okay, something I got. This is Rohan who sent me. Or who is this? Mithun.
Yes, sir.
Mithun, show me the mechanism. First,
Actually, I'm not having my mobile, sir. So I just wrote the product alone in the page, sir. Took a screenshot and sent it to you.
Is like C double one. Why is there a negative charge in the product? And look at the third carbon. Third carbon is having only 3 bonds. It should have 4 bonds. And even the fifth carbon atom is also having only 1, 2, 3, 3 bonds. 4 bonds should be there.
Okay, sir.
Check it, check it. Anybody else? I'll give you 1 more minute for anybody else if they want to send me. Okay. I think nobody else is sending me. Let me give you the answer. Okay. So let me write the compound here. So we have sent. Okay. 1 second.
But I'm not sure, sir.
No issues, no issues. We have that C minus will attack here, O minus, OH. Yeah, it's correct. Okay. Yeah. Fine. So we have this CH3. I'll write it as CHH because it's your alpha carbon, and we have your CHO, right? So first the OH minus comes. This bond breaks, and that this OH minus is going to take up the H plus. Okay. So we are going to form the carbanion now. CH minus CHO is going to be there, and we are going to make it attack the next carbon with carbon. CH3, CH2, C double bond with the H. Right? And this is going to come and attack the carbonyl carbon, and this bond breaks. Right? So what is the next step? We'll start with this CH3, CH3, CH2, CHO minus. I just wrote CHO minus, CHO minus, and this carbon is attached to this carbon now, right? So we have your CH that is having a CH3, right? And that is also having a CHO. Done? Okay. Then what will you do? You will take up the H plus to the oxygen, right? So you are going to form CH3, CH2, CH, OH, CH, CH3, CHO. This is what we have. Then what are you going to do? I have to remove the water molecule from the alpha position, alpha and beta. So you will remove this H2O, right? So if you remove the H2O, we are going to form CH3, CH2, CH double bond CH, no, not CH. The hydrogen is not there, people. Okay, hydrogen is now. Okay, now the hydrogen is not there. Okay, right? CH3, and that is attached to your CH. That's it. This is your final product. Okay, right? Fine. One more question. Let me see if this time number of people getting the answer should be greater than the previous case. I hope. Right? Do you guys want to copy this, or can I move on? I hope you're copied. I guess you want to go. You want to copy? Okay. Fine. So one more question we'll do. Say we have CH3, CH2, C double bond O, CH2, CH3. Okay, 2 times going for OH minus. Yeah, go ahead. So remember that this is alpha carbon, and again this is alpha carbon. Anyone you can take. No issues.
Since
Okay. 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 Yeah. Fine. But can you write it in the normal form, the final product, like how we write like this? Okay. This one, how we wrote. Normally, how we write the structures. Can you write it like that?
yes, sir.
The
Yes,
answer,
sir.
right. But just write it in a little more legible way so that you would understand.
Since
Hmm. Okay. Okay, it's Devesh, right? Okay. One, breaking that, H plus 2. And then okay. CHOH you removed, right? Ah, okay. Yeah, correct. Fine, people. I think I'll help you this time. Fine. So if I put OH minus, either this hydrogen or this hydrogen, anything can be removed, no issues at all, right? Say after removing the H plus, you would have had CH3, CH2, CH minus, because you removed H plus from this, right? CH minus and CH3. Now let me make it attack to the next carbonyl carbon. CH3, CH2, C double bond O, CH2, CH3. Now this is going to come and attack. Sorry. Right. This is going to come and attack this carbon, and the C double bond O breaks. Right. So now because of that, let me start with this. Okay, let me start with this CH3, CH3, CH2, CO minus. Okay, and let me write the CH2, CH3 down. Okay, and to that, this carbon atom is attached, and that is basically CH, right? Having a CH3. Let me put the CH3 at the top, right? And that is attached to this particular group, C double bond O, CH2, CH3. Okay, then eventually this is going to have a H plus also. I can directly write it here. This O minus would have eventually taken up a H plus. No issues. Now what are we going to do? We are going to remove H2O, OH from this, and H from this. Done. Okay, so the final product would be CH3, CH2, CH2, CH3, double bond C, CH3, C double bond O, CH2, CH3. This is your final product. Okay, right? So if it is better to write the structures in proper structures like this. Like if at all you don't write, like even though the structures are correct, right? But it is better to write in the proper format like this. Normally how you represent. Okay, right? So people, every time you don't have to go to the mechanism, right? Every time you don't have to go to the mechanism. Now I'm going to give you a shortcut for all the compounds which you have seen already. Okay, right? I'm going to give you a shortcut. Mechanism is very, very, very important. Yes, no doubt about it. But other than that, because every time you'll not be able to go for the mechanism and find the product, right? So I am going to give you a shortcut directly. Okay, so the first compound which we took was CH3CHO, right? Let me write it here. First compound we took was CH3CHO. Now, how are you going to write the product is like this? See, look at this. CH3, we have a CH double bond O. That's what we have. Okay, write it like this. Okay, now what you do is you take the alpha position. You take the alpha position, that is the next carbon compound, you take the alpha position, write it as H2CH. Okay, H2CH, and write the other thing directly. Right? Now what will you do is you will remove H2O minus H2O. Now you make a double bond between this carbon and this carbon. CH3, CH, double bond CH, CHO. That's it. This is your final product. Let us check what had happened to the final product now. Where were you? Where are you? Yeah, right here. Right, this is not the thing. CH3CHO, H plus. Yeah, this is your final product, right? So you can understand this is the exact product only we got here, right? But how will you get the aldol? Now, when you want to get the aldol, add H2O to this. Okay, little add H2O to this. You know that you have to form beta, right? You have to form a beta hydroxy aldehyde or ketone is what you have to form. So you have to add OH here, right? So you will form CH3, CH, OH, CH2, CHO. Guys, give me a moment, 1 second. Okay. So yes. So what do you do after removing a H2O? Like if you want to know what was the aldol form, you add H2O, making sure that you are having OH in the beta position. This is your beta position. Okay, right? Say the next compound which we took was acetone. Right? Let us see what we're going to do here. Acetone. Right? So we have CH3, C double bond O, CH3. Right? Okay. Now for this, how do we write? It is very simple. Let me write it like this: CH3, C double bond O with the CH3. I'll put it down. Okay, and you have to take the alpha hydrogens, alpha carbon, you have to put this side. So we'll write CH2H, C double bond O, CH3, right? So now easily I can remove this H2O, right? To form CH3, C, CH3, double bond CH, C double bond O, CH3, the final product. And then if at all you want to get the aldol, you just have to remember that in the beta position, you have to get a OH. This is your beta position, right? You have to get a OH there. So we will get CH3, COH, CH3, CH2, C double bond O with one CH3. Okay, right? So now what about the next one? Next one which we took was CH3, CH2, CHO. This is what we took, the third one. This is our second one. Right? So again, you have to be very careful in this. You have to protrude only the alpha hydrogen, people. Be very careful. So we will be getting like this: CH3, CH2, C double bond O with the H. No issues. Okay, CH double bond O with the H. Now you have to make sure that the alpha hydrogen is protruding towards this side. So you have to write it like this: H2C. Okay, and that is having a CH3. This I'm talking about this carbon that is having H2C, which is having a CH3, and that is attached to a CHO. This is how you must write it. Okay, so that you can easily remove your water molecule from the alpha position to form the final product. So the product will be looking like this: CH3, CH2, CH, double bond C, CH3 with one CHO. Done. And obviously the aldol product you want to get, this is where I should get the OH because this is your beta position, right? So we will get CH3, CH2, CH, OH, CH, CH3, CHO. That is your product. Okay. Can I do for the fourth one and check whether you're getting the same thing or not? For the fourth one, what we took was CH3, CH2, C double bond O, CH2, CH3. This is what we had. Remember that this is your alpha positions. So protrude it like this, what we did in the previous case. Okay, and you can get the final answer. Go for it, people. Show me the shortcut. As you once you're done, you can send me in WhatsApp. I can check. I don't know what was the difficulty here. Why it's so difficult? Let me help you with this. Say if I have, you know, you have to. Yeah. Send. Are you saying? Have you sent? Yeah. Got it.
So, sir,
Yes, I sent the final answer.
Yeah. No issues. Final answer. No. Yeah. Final answer is all right. You just have to show me the
Okay,
H2O.
sir, I'll send that also.
That will be better. Okay. You showed it like this. Fine, David.
Because on the mechanism I wrote in the previous page is again.
Yeah, mechanism not required. Mechanism not required. You just have to show me how do you remove H2O. That alone, if you show, the final product is very easy. That's it. Yeah, Devesh, this is correct. Right. So we will be writing it like this: CH3, CH2, C double bond. Let me write it here, and CH2, CH. Let me write it down. Okay. And you can go for the next one. Say you have to remove, you have to protrude the alpha hydrogen towards the oxygen, right? So let me put this as the alpha hydrogen. CH2, right? Now that is having one CH3. I'm talking about this CH3, and the entire group is attached. C double bond O, CH2, CH3. This is how I write this. Now easily you can remove your H2O to form CH3, CH2, C, CH2, CH3, double bond, C, CH3, C double bond O, CH2, CH3. That's it. That's your final product. Okay, right? So every time you have to go for the mechanism like this, we'll be able to show the shortcut and then get the final answer. Okay, fine, people. Now, till now, what we did is we have taken two molecules of the same compound. Isn't it? 2 moles of the same compound, and then we went for aldol condensation. What if I use 1 mole of one compound, another mole of another compound, right? Then also it can happen. Isn't then also aldol condensation reaction can happen? But in that case, I am going to call it as a special thing, right? I am going to call, we are going to see cross aldol condensation reactions. Right? Cross aldol condensation means what? Instead of using 2 molecules of the same compound, we are going to use 1 molecule of one compound, another molecule of another compound, another carbon compound. Right? So, for example, if I tell you that I'm taking CH3CHO with CH3, C double bond O and CH3, I'm taking these two and I'm going for OH minus. Okay, and I'm going for OH minus. Now tell me how many products are first possible? How many products are possible? Tell me. If I take these two, I'm taking 1 mole of this and 1 mole of this. Okay, right? So tell me how many products can be possible for this aldol condensations? How many products?
2, sir. 3, sir.
2.
3 products that may be possible.
3. Okay, fine. Anybody else has any other answers? One was 2, another was 3. Any other answers? The camera. Okay, right, people. So you understand that I can have self-aldol of this. What do you mean by self-aldol? This molecule reacting with this molecule itself, right? Second, self-aldol of this only. That is this molecule reacting with this molecule itself, right? Or I can have cross-aldol in 2 possible ways. One, alpha hydrogen removed from this, right? And the carbon anion attacking this one. Or alpha hydrogen removed from this and attacking this one. Right? So there can be 2 self-aldols and 2 cross-aldol reactions. Okay? Self-aldol we have already done. If at all I give you only this and only this, you know how to write the product. Right? Say now, let me do it like this. Right? Say I will, for example, let me take alpha hydrogen removed from this compound. Right? Alpha hydrogen removed from this compound, and that is going to attack this one. Okay? So let me write it like this. CH2H with the CHO. Now first put OH minus to remove this H plus. Okay, so we would have had CH2 minus CHO. Now in the previous case, what we did, this CH3 means this one attacked the same molecule, right? But in this case, we are going to take the next molecule like this, and that is going to attack here from this, right? So now the product would have been, let me start from this one, CH3, CO minus, and that is having a CH3, and then this carbon, and this carbon is attached. So you will have CH2, CHO, and eventually I'll have a OH also attacking H plus, right? Then what we'll do, we will remove one H2O, right? So we will form CH3, C, CH3, double bond, CH, CH. This is your final product. This is your cross-orbital product number 1. Right? So like this, the cross-orbital product and number 2 also. Now instead of taking alpha hydrogen from the ethanol, we can take the alpha hydrogen from the acetone, right? So like this we can do CH3, C double bond O CH3. And now if I put OH minus, say I'll remove hydrogen from this. So we will form CH3, C double bond O CH2 minus, and that is going to attack your next aldehyde in this case, CH3CHO. Okay, right? Then what is going to happen? Let me start with this one, CH3, CH, OH, obviously O minus would have been there and formed OH. And then this carbon is attached to this carbon now. So you will have CH2, C double bond O with one CH3. Okay, then what I have to do? I have to remove OH from this, H from this, minus H2O to form CH3, CH double bond CH, C double bond O, CH3. This is your cross-order product number 2. Okay, right? So again, I'll be able to do the same thing with the help of shortcuts. Okay, this is that of the mechanism. I can do the same thing with the help of shortcut. Let me see how to do this. Right? So we know, we already know self-aldols, no issues. So now I am going, if at all, okay, there are 2 possibilities. CH3, CHO, let me write it like this. And I'm going to remove alpha hydrogen from the acetone. So let me write it as H2, C. Okay, so H2, CH, C double bond O, CH3. So what I'm doing, I'm removing alpha hydrogen from this, oxygen from this. This is one product. CH3, CH double bond CH, C double bond O, CH3. This is one product. Another possibility is that we can have CH3, C double bond O. Okay, let me write it like this. Okay, C double bond O with the CH3. I'm removing oxygen from acetone, right? And I'm going to have H2, CH, CHO. This is your ethanol, right? So we will remove H2O like this to form CH3, C, CH3, double bond, CH, CHO. This is your product number 2. And other than that, you can have self-aldol of acetone alone, self-aldol of ethanol alone. That is also a possibility. Okay, right? So like this, whenever you go for cross-ordinal reactions, yeah, tell me.
So what is the difference between the second product and the first product, sir?
Nothing. Okay. In this case, what I did, in this case, I removed oxygen from ethanol. This is ethanol, right? Oxygen from ethanol. And I removed H2 from acetone. This is acetone. In this case, what I did, in this case, I removed oxygen from acetone, right? And I removed H2 from ethanol. That is the difference. You will look at the product, it will be different products, right? This is aldehyde, this is a ketone, entirely different products. Yes, understood?
Okay.
Right? Okay, right. So if I give you another set, will you be able to do? Say, I'm giving you, CH2, CH3. Okay, I'm adding these 2 with OH minus. Show me 4 products. All the 4 products I need to know. Show me the help of shortcuts.
So I have a meeting even the self-aldol and cross-aldol both.
Yeah, self-aldol. That means self-aldol of only this. That is one product. Self-aldol of only this. Second product. And if you remove oxygen from this, hydrogen from this one product, hydrogen from this, oxygen from this another product. Totally 4 products. Yes, understood?
Yes, I understand.
Okay, go for it.
Okay, something I got. Okay.
Yeah. First product is okay. Devish. Another one coming. This from this, this from this. CH3, CH2, CHO. Okay, you're going for self-aldol. Okay. 2 self-aldol products are okay. Done.
So I sent one product. So
Yeah, yeah. Which minus backing. Okay. Yeah, this is fine.
So for the self-aldol, is it fine if we write the product directly instead of showing everything?
No. Just you show the shortcuts alone. That is enough. Don't show the mechanism. Mechanism will take a lot of time. Show only the shortcuts for all the 4 products. Yeah, everything is okay. 1, 2, 3. Okay. 1, 2, 3, 4. CH3, CH2, CHO, 2 moles of that. Here it is CH3, CHO, CH3. Okay, this is okay. Yeah, everything is okay. Everything is correct. Okay. So first, let us go for the self-aldol products. Okay. So let us take the first compound only. This is first compound. This is second compound. So self-aldol of first only. That means we will write it like this: CH3, CH2, C double bond O, CH2, CH3. Right? We will put oxygen and the alpha hydrogen on the other side. So alpha hydrogen, let me take it like this: H2, C. Okay, H2. C, right? And that is having one CH3, right? And I have the C double bond O with CH2, CH3. Something I got. Okay, this is fine. Right. Okay. So now what are we going to do? We are going to remove this H2O. Right. So the first product would be CH3, CH2, C, CH2, CH3, double bond C, CH3, C double bond O, CH2, CH3. This is your first product. Okay. Now second product is going to be 2 moles of CH3, CH2, CHO. This is what we have, right? So now we are going to write it like this: CH3, CH2, C double bond O with a H, right? And then let me put out the alpha hydrogens only. CH2, one CH3 is here, and then we have a CHO. Then remove the water molecule to form CH3, CH2, CH double bond C, CH3, CHO. That is about the self-aldol products. 2 moles of the same compound, right? Now going to cross-aldol, right? Say, let me remove, say, CH3, CH2, C double bond O with the H. That means I'm going to remove oxygen from this, okay? And let me put out the hydrogen atoms, alpha hydrogen on the next compound: H2, C, CH3, C double bond O, CH2, CH3. Done. Now we are going to remove this particular H2O, right? So this is product number 1. Okay, CH3, CH2, CH double bond C, CH3, C double bond O, CH2, CH3. Done. First is done. Second case, I'm going to remove oxygen from this and hydrogen from this, right? So let me write it like this: CH3, CH2, C double bond O, CH2, CH3. I'm going to remove oxygen from this, obviously hydrogen from the other one. Right? So we can write H2, C, CH3, CHO. Right? Now we remove here H2O. Final product is going to be CH3, CH2, C, CH2, CH3, double bond, C, CH3, CH. That's it. This is your product number 4. Okay, very, 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 very simple. Self-aldol, 2 products, cross-aldol, oxygen from one, hydrogen from one, again vice versa. Hydrogen from the other one, oxygen from the next one. Like that, you'll be able to get 4 products. Okay, right? So that is about your cross-aldol. Okay, now there is another, what is the time? Okay, we have 10 more minutes. Right, so another kind of aldol reaction is what is called as intramolecular aldol reactions. Intramolecular aldol condensation we are going to see. Okay, what do you mean by intramolecular? Within the same molecule, I'm going to have the reaction. Right, so definitely what kind of compounds can give intramolecular condensation? If you have 2 C double bond O's in the same compound. Right, if you have 2 C double bonds in the same compound, then those kind of molecules can give intramolecular aldol condensation. How? Let us try. We'll take a simple example. Okay, say I have CH3, C double bond O, CH2, CH2, C double bond O with a H. Okay, right. Now you will have some confusions, right? So with respect to this one, this is alpha, right? With respect to this one, this is alpha and this is alpha, right? So many confusions will come, right? Which alpha hydrogen to take and do that, but take your alpha, carbon and attack it where, all those confusions will come. Right, people? So what you have to understand is, I don't think this is there in your syllabus. Don't worry about it. This is not in your syllabus. This is only for JEE Mains and Advanced and NEET for people. Okay, don't worry about it. Okay, right. Check in your book whether you have intramolecular aldol. I don't think you have. Okay, if you have that, let me know. I'll teach you. Okay, but I don't think you have that. Okay, don't worry about it. Okay, so that only 2 things are there. One is self-aldol, another one is cross-aldol. Another thing we have, but there is not there in syllabus. Okay, that is for little higher levels. Okay, right. So that is about aldol condensations. Now, next reaction, another name reaction we are going to see, that is what is called as Cannizzaro reaction. Right, Cannizzaro reaction, again very, very important. Just like aldol, this is also going to be very important reaction. Okay, right. So Cannizzaro reaction is actually a disproportionation reaction. We know what is disproportionation, right? Disproportionation. Okay, whatever it is, right? It is a disproportionation reaction. We know what is disproportionation, right? Same one compound will be there. That compound will get oxidized. The same compound will get reduced. Very, very simple. Again, I repeat. There will be one compound. Okay, that compound only will get oxidized and that compound only will get reduced. Those kind of reactions are what are called as disproportionation reactions. Okay, reduction, oxidation happening on the same compound is what is called as disproportionation. Okay, right. So in this case, we have to understand that what type of compounds can give Cannizzaro reactions? With the compounds which does not possess alpha hydrogens. Okay, so compounds which do not have alpha hydrogen give Cannizzaro. The compounds which has alpha hydrogens given by will be given for aldol condensation. Okay, compound having alpha hydrogen, aldol condensation. Compound is not having alpha hydrogen, Cannizzaro reaction. Okay, so for example, if at all I take benzaldehyde, I know benzaldehyde doesn't have alpha hydrogen, right? So it can give your aldol condensation. Here also we just have to use a base. Okay, that this thing is common, but except that there you go for dilute NaOH, here you have to go for concentrated NaOH. That's the only difference, but NaOH is the reagent here. Okay, right? So I told you that this is going to be a disproportionation reaction. So this molecule will get oxidized, the same molecule will get reduced. So you're going to get two different products. One is the oxidized product. I know whenever we have aldehyde and we go for oxidation, we are going to get acid. Okay, this is your oxidized product. Right now, the same compound is now going to get reduced. Now I know I have an aldehyde. Aldehydes on reduction will give us alcohols. Right. So now this one is going to give us CH2OH. CHO getting converted into CH2OH. CHO getting converted into COOH. This is your reduced product. This is your reduced product. Right? Okay. Now this is an example. Like I can have another example where this thing is HCHO. Right? HCHO again doesn't have any alpha hydrogen. So when I just put OH minus, so what is going to happen? This will get oxidized, that will get reduced. So oxidized product, HCOOH, right? And then reduced product, CH3OH. That's it. Disproportionation reaction. Okay. So this is what is called as Cannizzaro reaction. The mechanism of Cannizzaro reaction we will see in next class. Okay. We'll stop this for today. Okay. So we will see here also I can have cross Cannizzaro. Right? Maybe you understand you have to use two molecules of the same thing. Only then one molecule will get oxidized, other molecule get reduced. Same here. Too. One molecule getting oxidized, another molecule getting reduced. What if I use 1 mole of this and 1 mole of this? Right? Then we have to decide which will undergo oxidation, which will undergo reduction. All those things you have to decide. For that, we have to look into the mechanism. Okay. So next class, we'll be looking into the mechanism and deciding if I go for cross Cannizzaro, just like going for cross aldol, which will get oxidized, which will get reduced. I have to look into the mechanism for that. Okay. And I think after that, we have only one more reaction. That is your haloform reaction. Okay. That also we'll see. And with that, your aldehyde ketones part is getting over. No, we have your aromatic aldehydes and ketones also. So that is a very small part. So next class, I'll be completing your aldehydes and ketones and I'll be starting with acids. Okay. After is a very small part, very, very small reactions are there. We'll be able to finish that. Right. So most probably next class, I'll be completing this particular chapter, aldehydes, ketones, carboxylic acids. Okay. Right. Any doubts? Anybody has any questions to ask? Okay. Fine. If that's the something there in the chat. Right. Fine, people. Let me stop sharing. Let me stop the class right here. Right. And you can leave. Thank you so much. We'll meet again.
Thank you.
And one minute. Guys, this thing, what is that? We didn't have class on Friday, right? So we have to compensate it in the next coming week. So when do you guys in a weekday, you don't have class? Monday to Thursday?
It's on Thursday or Saturday, sir.
Or Saturday.
Thursday and Saturday we don't have any.
Saturday I have class. So Thursday we can have?
Yes, sir.
Okay, fine. I'll talk to Raghav. Maybe we'll fix for Thursday. Okay. Fine. Thank you so much, people.
Thank you, sir.
Thank you, sir.